Hello, so we are back, and this time we have a proper nice laptop to repair. So this job is coming from computer business, which I'm working a lot with them. And they send me a board. You remember, those are the people that are sending me candies, and I told them, don't send me candies because I'm fat. And now they send me board, donor board, please keep. I mean, I didn't want to keep the board, but if they said please, yeah, I have to keep it. Boards are better than candies. So what they are saying, hi Sorin, we have a Medion, has no power, but on further inspection I see a capacitor or MOSFET blown on the board. I have included the same board for you to keep it and use it as a donor board. Thanks. This is like a two-way sword. They included the board because they want me to replace the blow-up capacitor or for spares actually, huh? This is a nice way to say, sorry, we know you don't replace the capacitor, but I'm going to send you the board so you can get the same capacitor and replace it. I think that's what they're trying to tell me. Anyway, this is an i5 with Alexa built in. Interesting. Medion Akoya. I will say let's open the laptop and let's have a look inside. Screws left out. Okay, so we have no screws. And the laptop, it's open. Lol. I mean, check what is there. That's crazy. Not sure if you can see. I mean, the whole area is blown up there. I really doubt a spare board. It will solve the problem. But let's disconnect the battery first. Yeah, it is looking bad. It is looking bad. Okay, the battery is disconnected. Let's go under the microscope and have a look. I mean, 1 second. Okay, so someone try something because this thing is bent here, but it's still good. Check that, it's still solder. Yeah, we're gonna solder that thingy. You know what? They are right. I mean, it is looking bad. We have burn layers here, but it was a capacitor here. Yeah, here it was a capacitor. Wow, and we have burn layers. Check here. If we can remove the short of the burn layers, then everything is fine. I mean, here the board is not burned. Check here, you can see it. Yeah, here is fine. Here you have this MOSFET. Do you think, check here, here you have a mark. Here is sign of heat, you can see. Yeah, excessive heat. So this MOSFET, what is doing, driving this coil, which is charging the battery. Yeah. So this coil, you can see the output of the coil is going here, and we have a MOSFET, and it's going to the battery. So this is the charging circuit. Yeah, is the high side MOSFET. So this is the low side MOSFET, and this is the high side MOSFET. But I'm more interested if the main power rail is still shorted. Yeah, it is looking bad. Let's get a multimeter. Multimeter plus, and yeah, it is shorted. Check that, 0 ohms. 0 ohms. So how we can do it? Yeah, here is 1 second. Here is plus. So this is plus and this is ground? No. Wait a second. So this capacitor must be connected to ground. So which is ground? Yeah, this is ground. Okay, it is unexpected to see a resistor on the ground track. But here is plus, obviously, charging the battery. Here is minus. And minus is coming through this resistor, which is ridden by some, yeah, you can see the tracks are going here. Yeah, it's a current sensor. So here is ground, here is plus. Now we have to remove that capacitor because we really have to clean the border. I mean, it's not just enough to work now. It should be work, you know, even in 1 year. So we have to do a good job. The spare board is not really helpful. Here is looking fine. Yeah, here is burnt, check here. So this probably, it's under the MOSFET. Yeah, we have to remove the MOSFET. Let's remove the MOSFET. This is like, you know, burn layers is like cancer. So you have to clean everything of you know, of the burn area. Yeah, and the most, oh lord, it's looking proper bad. Check here. What is this? Huh? You know what? I need my knife. I want to keep this track here and cut. Yeah, like that. So now it's fine. So check there. The thing got burned till here. And of course now it's not sure because we remove the plus track. I can only hope. This is ground, what you see here? This is ground, this is the second layer. You have one layer of plus, then minus, then plus again. Good. Let's clean. But it's looking good, it's looking good. I mean, the burn didn't reach the other side of the board, so we are fine. We are okay. Yeah, check that. So if we are checking now for short, yeah, any short, minus, plus, no short, check that, no short. So here it is short, because here is ground. But here is fine, here is no short, it's fine. Perfect. So what do you think? It is this customer lucky? Yeah, it is. 1 second, this can be the plus track. Let's check with the multimeter. Plus, no, it's no plus track. No, it's fine. So this is ground, you can see. So it's no plus, but it's ground. So you have the plus on the top, then you have isolator, then on the bottom you have ground. Yeah, it's fine. It's fine. Then you have this isolator, and under this isolator you have plus again. So in this way the board is just a big capacitor. I mean, it's fine, you know. I was thinking that this ground to not reach the plus track from behind. Let's remove this ground because we have to come with the MOSFET. Good. And the MOSFET is not connected to ground. Yeah, looking good. Here is ground, is fine. Here was supposed to be plus, this is ground. If we are coming with a MOSFET here, you know, the back of the MOSFET, it will touch the ground, and I'm not happy with that. I think I'm gonna use what we should use. I mean, it's easy to use UV gel, but we are using UV gel and we have no cooling on the MOSFET. The MOSFET is cooling down using the board. No, I have a better idea. I mean, yeah, the MOSFET is cooling down using the solder. So we have 3 pins here and 4 pins here, and the back of the MOSFET, right? Check here. Yeah, I'm pretty sure this MOSFET is still good. But it's not necessary to solder the MOSFET here. We can solder the MOSFET here, which is even better because here we have some, we have mass, yeah, so the heat can get spread. So I think it's better to solder the MOSFET here. What do you think? Hmm? Because instead of soldering the MOSFET here and using a wire, it's better to solder here and use 2 wires. And it's not important if it's touching down. So it's a solid plan? I think it is. I think it is. So first, I will solder the capacitor back because we have no capacitor on this power supply. So in soldering the capacitor? Yeah. They sent me a motherboard. So the capacitor is soldered on place. Let's be sure it's soldered. Yeah, it is. Perfect. And here we have the plus, right? Good. And the MOSFET. Now check here. So if we are soldering the MOSFET to the capacitor and the resistor, we have a lot of cooling area. Good. So a lot of solder. My MOSFET. Can't believe. Yeah, that's the position I want. Yeah, that's what I want here. So not only we have a lot of solder here, but also, you know, it's getting cooled by the components and by this board. Yeah, so everything is fine. Now the gate wire is not that important, but the other one has to be bigger, you know, just to have like a low resistance and can move a lot of current. So I'm gonna use this. Yeah, this is a capacitor actually. Capacitor pin. Oh, this is. Oh yeah, I can. Oh lol. Perfect. So 1 second. The MOSFET is turned around, so these 3 pins, yeah. Perfect. But before we are soldering this, let me solder a wire from the gate of the MOSFET. Yeah, so the gate is soldered perfectly there. And the gate it is soldered. Perfect. We have a nice gate wire here. Let's solder this one. Yeah, all good. For me, it's looking okay. What about testing? Do you think we are ready for testing? Let's see. Plug in the battery. We didn't check if that MOSFET is shorted. Probably not. Probably it's not shorted. 19 volts. Good. Yeah, this one. So plug in the charger. It's shorted. I can't believe. What is shorted? Okay, let's check. So we ground short 0 ohms. I can't believe I worked so hard. Do you think actually this MOSFET is shorted? Or the capacitor? So what is shorted here? Okay, let me remove the MOSFET solder. I mean, that's the easiest way. So the solder from the MOSFET is removed. Let's see if we still have short now. So here is short. I can't believe. So actually that capacitor is gone because it was not short before. And the capacitor is removed. Let's see if we still have short. No, it's not short. Check here. No short. Okay, let's grab the donor board. I mean, yeah, we have exactly the same donor board. You can see it? Yeah. And here we have a big cap and we have two more. These two more is not important. Why is not important? Because we moved the MOSFET. We move the MOSFET next to the capacitor. My MOSFET, I can't believe. And same like before. Yeah, we need more solder. And also we have to solder the MOSFET here. Good. Yeah, we have the capacitor exactly on the MOSFET. So let's check now. We still have short. So from here is not short. You can see. Yeah, all good. Let's plug a charger. Where is my charger? It's here. Let's see now. So plug in the battery. Plug in the charger. Charger is plugged in and it's doing nothing. This is not a good sign. Okay. At least it's not short. Let's see the main power rail. So the main power rail is here. 19.4. So why is not charging? Okay, let's do something else. Yeah, let's disconnect. Actually, no, even if we are disconnecting. Yeah, let's disconnect the gate. So if we are disconnecting the gate, good. Now if we are shorting the gate, we drain. Plug in the battery. Shorting the gate, we drain. The MOSFET is gone, I can't believe. Check here, nothing happened. We are pushing 19 volts on that gate and nothing happened. Our MOSFET is dead, completely dead. And we work so hard on that MOSFET. And the gate is soldered. Okay, time for testing. Hot? No. Desk. Good. So plug in the battery. Plug in the charger. Wait, it's not charging. I mean, yeah, the current is very low. That MOSFET was bad. We tested. We short the gate, we drain. It's a high side MOSFET. This one got burned. I can't believe this MOSFET got burned. Yeah. Oh, that's crazy. I mean, I didn't think the MOSFET, you know what? Case where the MOSFET actually is burned but it's not shorted is very rare. Very, very rare. Good. Let's do a test, yeah? Let's see now. Working or not. Plug in the charger and it's taking no power. No power at all. Plug in the battery. You know, I've never seen this driver before. Yes, I'm pretty sure this is the driver, but never seen something like that before. Huh? Check that. Huh? Charging fine, right? Yeah. Unplug in the charger. Plug in the charger and we have the pre-charge current. Yeah, and then fully charged current. So 150 milliamps and now it's going to 1.3 amps. That means the laptop is charging fine. Why is charging fine? Because I'm sorry, you know, the things can't go wrong on my repairs. Not quite. So actually this was quite a hard repair. We are like 1 week later. And, you know, I managed to blow up the driver. Then I said, you know what? It's okay, you know, bad things can happen. We can fix them. So I moved the driver from the spare board because the customer sent me a spare board. This is equivalent with the BQ chip. So I moved the driver on the board and the chip and the MOSFETs, yeah? All three MOSFETs, 2 MOSFETs plus that one, all 3 MOSFETs blow up instantly, shorting the chip. And I was like, okay, you know, if it happens twice, yeah, means I'm doing something wrong. So I ordered a new chip and I redesigned the repair. I'm gonna show you because obviously if the thing blow up twice, means yeah, I'm doing something wrong. So I connect source and gate straight here on the coil. Then I use a wire for the drain and a capacitor straight to the MOSFET just to keep the ripple down. You know, like I said, you know, when happened twice, then you do whatever it takes to be sure you are close to what the manufacturer designed. The chip, this is the chip which I replaced it. I'm gonna show you I bought it from eBay. You know, when you order a chip, you don't really know if you receive like a good chip or something else. So I bought the chip from this seller, and the chip was working fine. BD99950. You can see here you bought this item. Quite expensive, but I mean more expensive compared with the bigger chip. But yeah, it is what it is. It worked. That's what is important. The lessons to learn from something like that is the things are not going as planned every time. Obviously, we are doing repairs. We are going around from what the manufacturer designed. And most of the time it's working. But sometimes, you know, like what happened here, I mean, I can't explain why my design blow up twice. The first design with I don't know, maybe because of my gate wire, not sure about that. So the laptop it is charging fine, 1.3 amps. Pressing the power button, the laptop it is coming on. Current is going up. We shall see the picture. Yeah, we have picture. And you can see there we have the charging sign on the screen. So everything is fine. Let me shut down the laptop. Shutting down the laptop. And we should see the charging current. Yeah, 1.3 amps. You know, I'm happy I helped this customer. I didn't expect the job to be that long, but happy I fixed it. So I'm gonna stop now. I will say thank you for watching. You know, like, subscribe if you like the video, of course, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection, and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.